still look at the anatomy of the brainstem, but now we look at the dorsal surface. And again, looking at the sketch. Let's look at the three parts quickly, as we well know them by now. So here is the spinal cord, border to this line is the spinal cord. The medulla. The pons. And the midbrain. Let's look at in more detail of their structures, notable structures. So the medulla can be divided into two parts. 1, 2. This part would be described as the closed medulla, while more rostral to that is the open medulla. This distinction is made because while in the closed medulla, the medulla's cross-section and size is very similar to the spinal cord, in the open medulla, on the dorsal surface, we can see that the midline starts to open up to make space of a fossa, the rhomboid fossa, which will become the floor of the fourth ventricle. So just at the rostral end of the closed medulla, we should see two pairs of bulges close to the midline. Here and here. These are caused by the underlying tracts and nuclei of the dorsal column. But in this place, at this level, we already talk about two separate tracts and nuclei, the gracile and the cuneate. Tract and nuclei. The gracile tract is carrying information from the leg and the lower part of the body, while the cuneate tract carries information from the arms and the levels above. This is the level where the tracts will reach the nuclei, the underlying nuclei, which are named the same as the tract, and they synapse over to the second order neuron, which will then cross over to the other side and will form the medial lemniscus. As I mentioned before, in the open medulla, we have an opening, a division of the midline, forming these fossa in between the two edges, and this will be one part of the rhomboid fossa. So as I mentioned, the rhomboid fossa is actually spread over the open medulla and continues in the pons. And it is named the rhomboid fossa because of its largely rhomboid shape. But remaining in the medulla, another structure we have to mention here, and this is just here in the corner, in the lateral part of the more rostral part of the medulla, where it almost meets the pons. And these are fiber tracts actually. And these are tracts which are going from the spinal cord towards the cerebellum. It's mainly an entrance to the cerebellum rather than an output of the cerebellum. And this is called the inferior cerebellar peduncle. This will allow, for example, among others, the dorsal spinocerebellar tract to reach the cerebellum on its way from the spinal cord. Moving on to the pons. In the pons, as we mentioned before, the rhomboid fossa continues on, so forming the full picture, the full floor of the fourth ventricle. But the biggest bulge, or the biggest or most apparent structure, is here, again on the lateral side, and that will be again fiber bundles going to the cerebellum, which are just behind the spine of the brainstem at this level, and this is called the middle cerebellar peduncle. This is when fibers, what we've seen on the ventral surface of the pons, the pontocerebellar fibers will cross over from the pons to the cerebellum. Going up to the midbrain, we should see two very obvious pair of structures. These are called the superior and inferior colliculi. Superior and inferior colliculi. And these will be special sensory centers. The superior colliculi are related to the vision, and inferior colliculi related to hearing, and we will come back to them in the lecture this week. We also find fibers need to come from the cerebellum towards the midbrain, and also some ingoing tracts, such as the ventral spinocerebellar tract, will reach the cerebellum through the, I should use blue, the superior cerebellar peduncle, superior cerebellar peduncle.